talk about these trig graphs, we're going to learn how to graph sine, cosine, tangent, cosecant, secant, cotangent, all that kind of stuff. Today we're just going to talk about sine now. Okay. And it's going to be really important that you guys know how to convert degrees into radians. So maybe you told me that you're going to multiply by pi over 180. Okay. Do you guys know what this would become if you reduce this? Pi over 2. Good job. Nice. Now, a couple of things. You guys are going to see the big 4 come up quite a bit. Now, what is, if you did 180, what, yeah, 180 is just pi. Good. Does anybody know what 270 is? 3 pi over 2. Good job. Good job. 3 pi over 2. Very nice. Now, I don't have it up here. What's 360 you think it would be? 2 pi. Good job. Because if you had 180 is pi, is it 180 times 2, 360? Yeah. Or you could just do your conversion every time. Okay? These are going to come up quite a bit. Now, when we look at a sine curve is going to be in this form. Okay? And not really. I mean, you have to know like the position of things. It's not as bad as what it looks. Like usually they'll give you an equation and you have to know like what the A stands for, like what the number in front is. You don't really have to memorize the equation. The amplitude is going to be the A value in an equation. So I like that one because like amplitude is like the first part, kind of like the alphabet. The A comes first, right? What the amplitude tells us is going to be the distance between. Let me show you a picture actually of what a sine graph looks like, so you guys can kind of get an idea. You don't have to do this yet. I'll just take a picture for you. Let me just do sine x. This is actually going to be the only time you're ever going to be in radian mode, ever. Okay. So when you guys look at a sine curve, actually, why don't you guys do it too? That'll be fine. So it may make sense. All right, go to your y equals c. Right. Yeah, you can do it now, later, whatever. Right. Type in sine x. Right. Once you guys have that in, go to your mode key. Right, we're going to highlight radian. You get one, so you can do it. And so that looks good. Now when you guys hit graph, what we're going to do, well, we're going to change it. Right. So you're going to go to zoom, choice 7 where it says zoom trig, ZT, trig or something on the bottom, depends what you guys look like. So go to choice 7. Choice 7, zoom trig. Okay, now is it bigger for you guys? Yeah. Good, okay. So I wrote the directions on the bottom of your sheet. I wrote it under like the note part, but this is fine. Okay, just so when you guys are like seeing what the A is, you kind of get an idea what we're looking at. So your sine curve is going to be like this wavy kind of motion. It always looks like this. Now, a couple things about a sine curve. Okay, our equation here was just basic, y equals sine x, very general. The amplitude is always going to be what goes in front of the sine, right? Whatever the number is in front of the sine. So when you guys look at the number in front of the sine, what is it? 1. Good, right? So you can think about it like that. My amplitude here should be 1. So if I cut this between the maximum and the minimum value, what's the height? 1. Just 1. Yep, so good. That's what the amplitude shows us. All right. If you cut it in half, the distance between the top part and the bottom part. Okay, so let me give you guys another kind of change this up a second. Okay. Now if I make my equation instead 3 sine x, okay, and I change this. Hopefully you guys might get something this easy where it's a multiple choice and they just say what's the amplitude. Okay, it is possible. They like to put weird questions like this on, okay, that are kind of easy. Right? So if I did 3 sine x, oh no, not that. Sorry. Would it just be 3? Yeah. Yep. That's it. Okay. So if I graph this, you can kind of see how it changes. Right? So see how the minimum and maximum numbers are a lot bigger? It's like stretched out. you get that? Saying one cycle. Alright, so the amplitude is going to be this part. Right, you get sliced it right down the middle. Right, you have 1, 2, 3, and then 1, 2, 3. And you put 4 in here, it'll be 4. If you put a half, it'll only be a half. Okay, I'm guessing you're understand that since we're doing blank look. I never know if you're bored or if we're confused. You're confused. Okay. So does that make sense, guys, what the amplitude is? Yeah? Yeah. Okay, great. Now the frequency is a little bit tougher. Okay. The frequency is going to be the b value in your formula. Okay. I remember it's what comes before the x. So when we look at, any kind of a sine curve, if I gave you guys something like, let's just do sine of, let's do 2x. So your frequency here is just the number that comes before the x. So here my frequency would be 2. Now what the frequency shows is a little bit tougher. Okay? And when we start looking at graphing these and kind of getting more into it, I think it'll make more sense. But just for definition purposes, frequency is going to be the number of full cycles between 0 and 2 pi. So if I graph this thing, it changes a little bit.
Wait, is it 3 sine 2x?
What did I do? No, I did sine 2x. So if you did 3 sine 2x, yours will just be a lot taller, right? Like up and down. So when you guys did all that changing of radian mode and you went into zoom trig, what things happen on your picture is it creates everything into trig. Now, when we looked at a unit circle, do you guys remember how we always did like 0, we did the 90, 180, and 270, and you found the points there? Well, it turns these little dashes into basically a 0, a 90, a 180, a 270, and a 360. So, I feel like am I missing a dot? Well, there's one here, one, right? Yeah. Okay. So, instead of the 90, 180, 270, and 360, sorry. What you guys are going to see is things in radians, not degrees. So, when I first had you guys do your converting, what was 90? Can you remember? Pi over 2, good job. And so really what we're going to see is this. This is going to be your pi over 2. This is going to be your pi. What would 270 be? 3 pi. Good job. And then this is going to be your 2 pi. Does yours only have 4?
I did the Zoom thing.
No, this is good. I feel like I have too much on mine.
If I did the
That's fine.
I'm terrible.
I don't know my calculus because it's like the updated thing. It looks weird.
Yours somehow like stand out.
Yeah.
Mine has this one, like I can't really tell.
Yeah, does yours end here?
Yeah. No, mine ends on the
I have Zoom out.
Mine would end on the
No, it's okay. This is fine. We can do it like this. Now, if they ask you guys the frequency, we probably won't finish today, which is fine. It's not a big deal. So they looked at the number of full cycles between 0 and 2 pi. A sine curve always looks like this. Right? That's always what a sine curve is. So when we look at the number of full cycles between 0 and 2 pi, let me go back to my graph. Okay. Right, we're always going to start at 0, and we have to look at this part. That's going to be 1. It goes all the way back up, down, and around. And we have another one. So this is like 1 and 2. That's why when we graph this, the frequency was 2, and between 0 and 2 pi, I see 1, 2 full cycles. Now if we try, let's change this again so you guys can kind of get an idea. If I just did, let's make this 3 sine x. And we graph that thing. Y equals 3 sine x. Right. This time, what would your frequency be? What's the number in front of the x? It's not there. It's front of the x. 1. Good. Okay. So here, the frequency is 1. Right. Maybe you're trying that. So that means between 0 and 2 pi, I should only see one full curve. So let's check this out. Right, here's your, this is your pi over 2, that's the 90. Here's your 180. Here's your 270. And then your 360. Okay, so we're going to look between 0 and 2 pi. This is always what the frequency shows you. Okay, so we look and kind of graph, we go all the way back up, down, and around. That's going to be one full sine curve. I know this is like a really boring thing. It's weird, I know. I just want to make sure you guys really get the idea before we actually do problems. Alright. Now the period is something that's great. It's super easy, you're just making a substitution, right? If you could figure out what the b value is in an equation, just the number that comes before, you're just plugging it into a formula. This one you do have to memorize, yeah. Thanks. Yeah. So if I gave you guys, for example, say y equals, let's do 2 sine of 3x. Okay. And I wanted to find the period. What would you guys use for your b? What's the b value? 3. Good. Yep. Very nice. So if they ask you guys anything about the period, you need to know your formula. 2 pi over, and then whatever your b is. You guys are going to see things that are always positive for what you guys have. Right, so 2 pi over 3. That's it. Nope, that's literally it. It's like a direct substitution. If you can reduce the numbers, you want to reduce, but that's really like it. What? No, they keep it in, because the reason why they keep it in radians is because on this, you work in radians now. So they kind of leave everything.
Do you have to memorize the general form or the
Anything that I've seen, guys, with the general form, so if someone else asks this, they want you to write an equation, they give you this to use as a substitution. So they'll give you this part and they'll have you guys maybe figure out what the A, B, and C would be. So they'll kind of set it up for you. Let's see. Now a horizontal shift and a vertical shift, I don't see too much of the horizontal. Right? If you guys had anything in parentheses, and we've done this back in chapter 4, but it hasn't come up in a long time. If you saw something in parentheses with your x, this is the horizontal part. Right in here. So that kind of tells you guys if you were going to push your graph to the left or to the right. But the tough part was it was always opposite. Right? If you had a minus, you actually went to the right, and if you had a plus, you went to the left. Does anyone remember that? The opposite thing, maybe a little bit. So if you had, right, let's say in my problem, more space in there, I should make this bigger, sorry. I gave you guys something like y equals, 2 sine, and then I have x minus pi over 2, I don't know. So whatever's in the parentheses, this is always going to be the horizontal shift. And the thing that I would ever see with this for you guys is, I don't know if they even had a question with a horizontal shift where they had to talk about it. They might say, which way is this shifting? So if it's a minus, we're going to go to the right. Yep. So all you guys would have to say is it's going to shift right pi over 2 units. That's it. All right. You won't get into these big shifts until 3,000. Actually graphing them with one or recognizing it. Right. What you guys need is just understand that if it's minus, you go right. If it's a plus, you just go left. Right. They'll just ask you maybe about the direction if they ever did anything. I do see things about the vertical shift though, and this is much easier to recognize, right? It's always at the end of the equation, or you could actually have it like in the beginning part, but it's like separated by addition, it's like its own thing. And that represents like how far up or down it would be moved. So if you had like a plus d, we go up. If it's a minus, we go down that amount. That's it. That one's kind of nice because it like actually makes sense with what it would be. Okay, so just a little bit of stuff. When you guys are graphing, right, make sure we're in radian mode. And then, can I add it on here? Hopefully you want it there. No, I don't know why. Right? Zoom trig. It's on your paper, but I don't know why it's not here. Right? Choice 7. You're going to be dealing with that a lot. This whole chapter is basically like graphing things, making sure you guys can match up the pictures. A basic sine curve, and this is something that's kind of cool. We'll probably end on this part. A sine curve always starts at 0. Sorry, Ash, do you mean you're singing? Okay. Right, so the sine curve is always going to start at 0. It has to go up, down, and around. Now, it's modeled off of your unit circle. So this is like your basic unit circle, right? Your 0, 90, 180, and 270, 360. So your sine, if you think about it, what's your sine here at 0? Which part was it? The 0, right? Your sine came second. So look at your first point. At 0 degrees, we're at 0. When you moved up to the 90, the pi over 2, what's your sine here? 1. Okay. What's your sine at the 180? 0. So that's why it's hitting again back here. 180. What about the 270? What's your sign? -1. Good job. Yep. So the -1. So now we're down here at -1. And then back the full way around. If you guys went to 2 pi, you have to hit back at 0. So when we connect this, it's a nice little curve. Okay. That's how they're getting all these like values from unit circle. Now, that's just like a general one, since they're general unit circles. You guys kind of saw how things can be like higher, lower with stuff.
Yeah. Does that mean that like, for the frequency, how we need to go like 0 to 2 pi? Isn't that always just before going over?
Yes. Yep. We're going over. Good. All right. So this is all I have for you guys for today. We're going to finish